An invitation to the conference. I'm coming from Lithuania. This country is as 2 times larger than Taiwan, but population is nearly 10 times less, so we cannot develop so big ecosystem in semiconductors as you, but nevertheless, we are strong in some kind of the lasers, not used for communication, but mainly for material processing. So I'm coming from a Center of Physical Science and Technology, the largest research institution in Lithuania, working in different fields, as combined different institutes together in advanced materials, surface chemistry, environment, and of course, photonics and lasers. I'm leading department of laser technology by developing optical coatings, lasers itself, laser material processing technologies, laser for communication, manufacturing, and those are examples of complicated coatings for special applications, lasers, and some examples of laser processing, and also we're working on laser communication and quantum. So I also represent Lithuanian laser ecosystem, so it's a combination of research institutions at universities, laboratories, but we also have don't go back. Okay, so we have companies working on optical coatings, optics, laser developments, and it's something here. Sorry. Optical coatings, optics, lasers, laser technologies, laser applications. We have all these value chains that we can do from developing specialized tools and use this for material processing, and all those lasers mainly are ultra-short-pulse lasers, specific applications. We have also some companies working on metrology, and very few of the companies working really in semiconductor photonics. Not too much of them. And you see, we are only a little more than 2,000 people working in this community, but nevertheless, we're working in the field that could be interesting for Taiwanese market, and we see some laser processes in semiconductor industry. That's one is in the chip manufacturing. Of course, its main processes, lithography, annealing is not our business, but when you go to dicing, slicing, or mask cutting for your processes in developing devices, our lasers can be a choice for those applications, especially when you're going to new materials like silicon carbide or even diamond. There is processes like slicing that you need to add. We're looking on advanced packaging when the chips are manufactured and separated from the vapor. So there are through silicon vias, through glass vias, RDLs, fan-out packaging processes, and also lasers can be applied, helping in your processes, simplifying some of those processes. And of course, there is going to assembly of electronics, where it's lift-off processes, deposition of micro LEDs or interconnects for various applications for assembly of electronics, or is stencil cutting or soldering. And if you look on those interconnect formation with lasers in chip packaging or assembly, we see that there are laser direct writing structuring technologies with laser modified materials, and after that, metallization could come on localized places, and we have some specialized technology developed in our center. We call it SAILS, with selective surface activation. We can work on it. And also there are processes with laser can induce graphene-like materials that is conductive, and that electroless or galvanic metal plating could make to increase conductivity on these areas. And more technologies like direct printing with silver-based or laser-based dry printing for metallization, for interconnect metals. And the most simplest way, so it's when you have deposit film, metal film, and after that, with the laser, you can ablate selectively, removing this material from this. And in quite a lot of most of those processes, ultra-short-pulse lasers we can develop in Lithuania are beneficial. And that's one of the examples is our process we had developed. So we used ultra-short-pulse laser to write circuit on a dielectric surface. There is some chemical activation process, and after that, electrolysis places, and you have component with electrical traces, even on 3D, on 2D. With this, you can go to very narrow traces of metallic lines with small pitch between those lines, quite high speed, and it's also with a high adhesion, and it works on most of the electric materials, plastic, glasses, and ceramics, and it's commercial material without any additives that for this, and some list of materials used also in semiconductor industries that we tested for these processes. And just to look how narrow lines can be do, coming to a few micrometers, and also very high adhesion coming to substrate, the electric substrate, because it's ultra-short-pulse laser interaction with the material. And just examples of flexible PET substrate metallization. With this technology, it was shown, but plain nitride a few days only made some micro LED display. A few years ago, we made mini LED display on glass substrate with a laser, and we write circuits on both sides, drill hole with the same laser, and that is coming plating, and after that, commercial SMD assembly on both sides. It's really do. And also, we can do this on ceramics materials. In this variety, we have the technology that can add metallic interconnect on different materials, also can get for heterogeneous integration when you need combined different substrate and widths. And again, it's coming those from this using ultra-short-pulse laser that makes technology universal. And advanced chip is coming now. The chips becoming more complicated, and they're split to the chiplets, and they need to be connected together with quite complicated structure. We also look how our technology could help in this field. So we are looking on how narrow lines we can do, how dense we can make those interconnected on polymers and the electrics used in chip, RDL formations, etc. There are some examples of panel packaging level RDL formation, and that is next level, next layer is built on top of that. And with this, we're going again up to 2 micrometers line width, and it's as we use laser direct writing for this process, we have this, with the same process we can do drilling holes if you need to interconnect between layers in those RDLs, and also we can write another some circuits on the packaging and makes also some wraparound. And if we compare also standard RDL process, there are in lithography there are different steps when you need deposit photoresist, and that's metal layers, etc. In our case, we have it on the polymer. We write with a laser beam, and we have metalizations. It shows that could be very promising because we are reducing quite a lot of steps, and we go up to 1 micron resolutions. Of course, upscaling process is needed because it's laser writing in sequencing. And it works very well with the glass, and with very good resolution we can do this on the surface of the glass. we can go right around with a laser beam, right, and other plating on the edges. It could be used also for some stitching displays, etc. applications. And also with the same laser, we can drill holes and the same metallization. That's some interconnects coming to that. It helps again with this, narrow lines, small pitch, quite high splits, and high adhesion. It show promises in different kinds of applications. It could be also for the high power applications of the lasers. And it's through glass vias also coming, because it's glass becoming now it's more important for some applications. With femtosecond lasers can easy drill millions of holes in a minute. Still, there are some challenges in uniformity and missing holes. There are, with a new kind of the lasers, gigahertz burst, it works. Also, can we make those holes with a little different shapes, but without etching, so we can do also direct plating without an activation in these fields. And that's still drilling it in this case a little slower, but there is no etching steps. And so we see opportunities, those ultra-short-pulse lasers in semiconductor for integration, because it's a fast and flexible way to do this with the right choices of substrate materials, and we see that we can reduce process steps in packaging processes. And for that, it's thanks. It's very short. We started also chip competence center, like was shown from some Netherlands. I am coming back with my education in semiconductors and all life in lasers, coming back to semiconductors. And again, on a semiconductor conference. Thanks.